Good evening, everyone. My name is Hector Olvera, and I am the leader of team number 1 in the class of Aerospace Systems Engineering. And I am going to present the PDR that we did. The team is made up of 5 members: Mabeli Hernandez, Ivan Murillo, Jorge Romo, Kenia Uranga, and your server, Hector Olvera. Our professor in this assignment is Eloy Normando Marquez Gonzalez. The first thing that we are going to analyze is the work team. As we can see, I am going to be the leader of this team because uh, as a group we decided that I will be the leader and the sub leader will be Mabeli. The rest of the team will be members guided to fulfill the different activities planned during the semester. Now, let's analyze the objectives for the project. The main objective of this project uh, is to develop a satellite can-size and achieve a series of specific requirements that should accomplish during all the life cycle of this project. Also, we are going to create a good environment for teamwork between us. As a leader, it is important for me to satisfy the main objective of this kind of project and at the same time create an optimal environment for the members of my team. This is because a team and the environment with optimal conditions can bring the best thing of people and subsequently uh, a good response to orders. If I decide to be putting pressure and continuously uh, like bad mood over my teammates, they will be frustrated and we cannot achieve the main objectives as as what we have planned. Now, let's focus on the requirements of this competition. At the beginning, we read all of these requirements of the CANSAT competition. And what we did was to separate separate them in different areas. Here we can see the first one that we create, and it is functional and performance. How the system should work and how it should develop. Some of these requirements, as we can see, will have some attributes and will have a smart analysis. For example, uh, we can see the container shall not have any sharp edges. This is something feasible and achievable. Why? Because we want to avoid any kind of malfunction in the rocket and in the parachute when the rocket and the science payload separate. So, avoiding these sharp edges, we are we are avoiding malfunction when the rocket separate, as I said. Another requirement here could be also the container that shall be solid. And this requirement has the attributes of feasible and logical. Why logical? Because if you think about it, the structure should be solid and not something, let's not say the weak, weak structure. It has it has to be uh, in optimal conditions, and it has to resist some pressure and some acceleration to accomplish the launch. Here we have a requirement that is graded in blue letter. Why is this? Because when we read the full requirements of this competition, we we saw that some of them were not completely clear. So we have to put them in a main idea and make a transcription of that requirement. So here it is an example. All mechanisms must maintain their configuration and resist to meet their design objective. As we can see in this requirement, the structure should contain maintain their configuration, but also resist uh, all the forces involved during the launch to be able to reassembly and make another launch. So we can make various launch during the project to see if it is working uh, in good conditions. And here we saw some requirements that are not in blue letter, but are completely in blue. Why is this? Because these requirements are repeated over the document of the cancer competition. So it is not necessary to make another analysis of them to to bring to the same conclusion. As we can see, there are some of them that are in blue because they are they express the same idea, the same main idea, but with different words. Here are other kind of requirements, and these are the constraints, the limitations that has to accomplish the structure. As we can see, the CANSAT shall be 600 grams, more or less than 10 grams. Why is this? Because we are forcing to create a system with specific measures, and this kind of requirement is something clear and feasible. It could be also achievable because we have to be in that standards to if we wanted to participate in this competition. Um, Here is the same thing. There are some requirements that are repeated, and for example, other requirement is the budget of this project for this competition. The concept shall be under $1,000. Why is this? Because we are trying to develop a specific structure that is cheap, but but can accomplish the specific requirements and bring that in the competition. Now we will focus on design and interface requirements. In this part, as the name said, is for the design and how the system will operate. One of these kind of requirements is that the container shall be fluorescent color. This is something clear and something achievable because you only need to paint the container with one of those specific colors, pink, red, or orange. And also, it has to have the parachute with a fluorescent color. But in this case, it is only the pink or orange color. Mm, well, here we have how the communication between the satellite and the main structure and the team should be. And here it is in the requirement number 20. The XBEE radar shall have their net ID or PAN ID set to their team number. How is this if our team is with the number of, let's say, 15? The the radio, the net idea should have the number 15 to so we can distinguish it from the other for the other teams. And here we have another kind of requirements also in the same area of design and interface. And we continue with those. Now, these are some added requirements that we propose. The first one is that the repair cost after a launch, in case that is damaged, the cassette shall not exceed the initial cost. So, in case that we have any malfunction or any kind of error during the launch or during the proof of, well, not the proof, the test, the cost to repair that malfunction should not be over $1,000. This is something logical and something clear because you cannot spend more to repair the main structure than what you have to of what your budget is to develop that main structure. Uh, Also, we have another requirement that we propose, and it is to the total temperature of any component of any part of the system of the structure shall not exceed 100 degrees. Why is this? Because if the material is not optimal to resist over 100 degrees, then it could bring a malfunction, and even it could explode, and we can lose our payload. That is our what we are trying to bring safely during the launch. Now, here we have the multi-attribute utility analysis. And here we are going to score all of these requirements in a scale of 1 and to 10. 1 is for easy and 10 is for hard. As we can see here, there are some requirements that will be easier than others. Why is this? Because when we are developing the structure or the design or the manufacturing of the satellite, we are going to visualize which of these will be harder than others that we have. For example, here here we have the requirement number 12 that score a number 10. This means that this requirement is the hardest or one of the hardest to achieve. Why is this? Because the structure shall be built to survive 30 Gs of shock. And we cannot, at this point of our career, we cannot imagine how many or how is that kind of force, that 30 G's force. And that's why this requirement could be harder for us to achieve, because we are not used to see this kind of forces in our daily life. As we can see, there are many of them and different scores between 1 and 2. I'm sorry, between 1 and 10. Every one of them, every single of them. And here we have a graphic. This graphic, what it means is that when a requirement is closer to the number 1, it will be easier to achieve. As we can see in the graphic, there are two requirements that will be easier for us to achieve than others that we could imagine. And here, as when the score or in the graphic is closer to 0, it means that it will be harder for us to achieve, as we can see. Now, for the system architecture, we analyze the PUC matrix and the multi-attribute utility analysis. And we conclude that we should focus our efforts in the main structure and the physical properties that must achieve. Why is this? Because the main objective is to create this CAN satellite and launch it and bring that science payload safely to ground after the launch. And that's why we should focus in the structure, because if there is any malfunction in the system, then we compromise the payload to not complete in optimal conditions this launch. Here we have a OPM diagram, and as we can see, as a CANSAT team, we are going to develop the design and the software of this project. And for the design, we are going to focus to the materials that should be optimal for our structure, and the cost, because we have that limitation that we are not going to, we cannot exceed $1,000. And also, it's going to we are going to focus on the software, because once the satellite is launched, the structure is going to transmit some telemetry data to us in the ground station. That's why we are trying to focus on this part also, because we need that telemetry, that data, to analyze if it's achieving as what we are expecting. Here we have the system concept of operation, the CONOPS, and it is the organization, the design, development and creation, and the checklist. As we can see in this diagram, the first thing is the launch well, the launch weight, the pre-flight test. After this, we are going to launch the rocket and the payload at one point of the at one point in altitude will be separate of the main structure, and the parachute will activate to bring it safely to ground. And here is where are going to recollect all of that data, as we can see. Um, Here we have still the CANOPS, and the CANSAT electronics switches are turned on, moved from launch to pre-launch stage, a final checkdown checklist before we move to the launch or the pre-launch. The payload descent rate is less than 20 meters per second. This can be changed to rate of increasing due to gravity, but remaining under this quantity. Also, here we are seeing the G forces that our structure should resist. That is between 15 and 30 G forces. Now we have the different operational stages. The first one is the pre-launch, and there are some requirements that it should accomplish before moving on to the next stage. For the pre-launch, all mechanical parts shall be in correct position. Circuits are checked. Telemetry mechanism is providing data. Here in the telemetry mechanism, we are going to make a simulation to analyze if it is working correctly. Now, in the launch stage, there are other requirements. For example, the rocket is set in a safe position and orientation. This is because we are trying to avoid any catastrophe or um, any accident during the launch, and to bring the system to the final stage, that it is the landing and the recovery of the data. Now, once the launch is started and our and and this, well, once the altitude is 700 meters, the rocket is going to separate. So the science payload will activate the parachute and finish the cycle. Now the science payload deployment, where the science payload is deployed immediately once the rocket is completely separate, and also the descent with air braking or with the parachute. Uh, then we are moving to the landing phase, to the landing stage, when the CANSAT and the payload uh, touches ground, and finally recovery of the data and also of the different of the different parts of the system. Here we have the preliminary budget, where we are trying to put in numbers how much it will be for every single part of our system. As we can see, the parachute, it could cost $20. The printed rigid airfoils can be from 100 to $220, and so on and so on. With this, we are trying to make a range of our budget and try to not exceed our limitations, that it is $1,000. Here we have a preliminary design. As we can see, it is something basically is the parachute. The GPS is going to be over here, also with the sensors. Here we have the microcontroller, the battery. This is the aluminum can. The switch is going to be over here. The photographic camera will be under the structure, so we can take those photographs while it is landing. And this is the whole structure. For our preliminary design, these are the various components that we are assuming to use. Maybe we can change one of them for another with better specifications. But here are some of them: the microcontroller, an Arduino Pro. The pressure measurement is a breakout board, battle, light measurement, TSL 2561, temperature and humidity, also here, the servo motors, the GPS, the transmission of data, the XBE, data saving is in a micro SD card. The MIMU 9B2 for the roll and pitch measurement. Our camera, another servo motors for our camera control, and the batteries for the components power and the camera power. And here we have a regulation for the voltage. Finally, we are going to see the program schedule that we have. As we can see, the first A1 was between for the 24th of August and was finished in 18th of September. So we have 25 days. The A2 requirements, it started in 18th September 18 and finished in October 6th. These different assignments or tasks were assigned to all of the members here, as we can see. Perhaps in the last part of the activities, there are not all the team, but this is because some of us were working or were in a different time, because due to the geographic position of us. So this is all for my part, and I hope it's get clear. Any doubt here in the comments?